Welcome to today's video on tests of significance. In the previous video in the biostatistics series, we saw about the measures of descriptive statistics. Tests of significance are classified under inferential statistics. Tests of significance are a method of reaching a conclusion in favor or against a hypothesis based on the data that has been collected. It may also be defined as a statistical method in which we use the sample data to test whether an observed difference is statistically significant or not. Let us understand the two statements with an example. Suppose the hypothesis that we have is that a high protein diet can increase the weight or can result in weight gain. Then we may design an experiment with two groups of animals. Initially, we will begin the experiment when the weights of the animals are similar in both the groups. Then, for a particular period of time, the control group will be given a normal diet and the test group will be administered a high protein diet. After a period of administration, then the weights of the two groups will be compared. If we observe a statistically significant difference between the weights of the two groups, we will go in favor of our hypothesis. We will say that a high protein diet can result in weight gain. But if we observe no statistically significant difference between the two groups, then we will go against the hypothesis and we will say that a high protein diet cannot result in weight gain. So both these statements help us to understand what is the role of a test of significance. Examples are students' t-test, ANOVA, chi-square, etc. Moving in detail, hypothesis testing. So, a test of significance comes into play only when we have a hypothesis to be tested. The same point that we said in the previous slide, to decide whether to go in favor or against a hypothesis can be made much more clear when we state it in the form of a null and an alternative hypothesis. So, according to the null hypothesis, always the statement is there is no significant difference, no effect, no relationship, etc. So, for the above hypothesis, we will state that a high protein diet does not result in weight gain. Complementary to the null hypothesis, we have an alternative hypothesis statement which states that the high protein diet can result in weight gain. So, to understand better, suppose we are testing a drug for malaria, then the null hypothesis statement will be the drug is not effective in curing malaria, whereas the alternative hypothesis will be the drug is effective in curing malaria. The significance test will be done to decide whether we are going to accept the null hypothesis or whether we can reject the null hypothesis and accept the alternate hypothesis. So for doing the significance test, first we have to choose an appropriate test. So there are types of distributions like T, F, chi-square, etc. They are chosen based on the particular experimental design and the requirement. So for example, a t-test may be chosen for the example that we discussed. When we have two groups and when we are going to compare the means of the two sample groups, then we can go for a t-test. When we have more than two groups and we are comparing the variance between the groups, we want to check the efficacy of a fertilizer, then we may have four plots of land. In one plot of land, we will have the no fertilizer treatment. In one, we may have a chemical fertilizer. One, we may have an organic fertilizer. And one, we may have a biofertilizer treatment. Now, to compare these groups and see if there is a statistically significant difference, we can use ANOVA. For categorical variables, we can use chi-square. For example, suppose we want to check how good an immunization is. So, we may be collecting a data out of the immunized people, how many had the disease, how many did not get the disease, and in a group of people not immunized, how many had the disease, how many did not have the disease. So when we have data of such nature, we can use chi-square for our test. Once we have a hypothesis to be tested and we have decided on the suitable test, next we have to compute the test criteria. And in the case of t-test, the value calculated will be t value. In ANOVA, it will be an f value. And in chi-square, it will be the chi-square value, which will be calculated using suitable formulae. And we can also compute the p value when we do it in a software pack. Then the decision is to whether accept the null hypothesis or reject the null hypothesis. In life sciences, the level of significance for decision is taken as 5%, which may be indicated as P.05. So, the level of confidence in this case is 95%. That means there is only a 5% likelihood that the correct null hypothesis is rejected. That means we are 95% confidence about rejecting the null hypothesis. So, when we directly get the p-value in a software pack, if we get the p-value greater than 0.05, we will say that there is no statistically significant difference and the null hypothesis will be accepted. But when we get a p-value which is less than 0.05, we will say there is a statistically significant difference and the null hypothesis may be rejected and the alternative hypothesis may be accepted. So it is based on 5% level of significance in life sciences. If the null hypothesis is rejected, that means your p is less than 0.05. We can also check if p is less than 0.01. If it is so, we are rejecting the null hypothesis at 99% confidence level. And if the observed p value is found to be also less than p.001, then we are 99.9% sure about our rejecting the null hypothesis. Suppose the value is computed and we are getting the test criterion value, then suppose you are getting a t value, then rejection is based on comparing the computed test value with the table value at the particular level of significance. In this case, we will always start with p.05. If the calculated value is less than the table value, we have to accept the null hypothesis. But if the calculated value is greater than the table value, the null hypothesis may be rejected and the alternative hypothesis may be accepted. If our computed value is greater than the table value at p.05 and we are sure that we are going to reject the null hypothesis, we can also check the table value at p.01 to see if our test criteria value is greater than that. If it is not so, we have to only take the decision based on p-value of 0.05. But if you find that the computed value is greater than the table value at p.01, we can mention that the decision is taken with a 99% level of confidence, p less than 0.01. And if your test criterion value is also greater than the table value at p.001, then we can mention that we are 99.9% sure. So once we have seen that our computed value is greater than the table value at p.05, we can check at the table value at p.01 and p.001 and then tell at what confidence level we are rejecting the null hypothesis. Two types of errors occur based on the significance level that is chosen for decision. The first type is the null hypothesis is true, but we reject the null hypothesis. This may happen when we choose a level of significance 10% and above. Like for example, at a confidence level of 90%, if we are rejecting the null hypothesis, then this type of error may be occurring because it may be true, but we are rejecting the null hypothesis. The second one is we have to reject the null hypothesis, but we fail to reject it. This may happen when we choose a level of significance below 0.1%. That means when we decide on a level of confidence more than 99.9% to reject the null hypothesis, then we may fail to reject the null hypothesis, though it has to be rejected. In life sciences, therefore, we are choosing the 5% level of significance to decide on whether to accept or reject the null hypothesis. About the t-test and how to carry out the t-test using Excel and Excel data analysis pack I have explained in one of videos. Thank you.